We are going to talk about some geometry basics so that we understand some of the vocabulary and types of objects that we are working with when we work in a basic geometry course. So in high school geometry, this is known as plane geometry, like a flat surface, or it could also be called Euclidean geometry because it's named after the mathematician Euclid. So we work with some things that are called undefined terms. We don't give them a formal definition. It's more of a description of what they are. And the first one is a point. If I ask you to describe a point, what might you say? You're probably going to say a dot or a circle. Well, a point actually isn't a shape. It is a location. So in algebra, you talk about an XY coordinate for a point, and that's kind of the address for that location. So a point doesn't really have any distance, there's no diameter because it's not really a shape, it's a location. So we're going to make notes: no shape, and that it is a location. All right, and then the next item that we're going to talk about is a line. If I told you to draw a line on a paper, you would probably draw a line with a pencil, and we would call it a line, but it really has a width, and you can measure it. If you think about mechanical pencils, they come in a 0.5 millimeter length or width and 0.7 of a millimeter in width. And so we see that there is a way to measure these, and these definitely have a width. But a true line has no width. It is a infinite sequence of points, essentially. And so this is made of infinite points. And has no width. So those are a couple of things that we want to note about this. The next thing is we're going to talk about a plane. So as you look at the progression here, you will see we started with a point, and then if you kind of stretch that out infinitely long, you have a line. Now we're going to come the other way and stretch that out infinitely wide and have a plane. So one way to visualize a plane, you could think of an infinitely big sheet of paper. But it has no thickness either, but it expands infinitely in each direction that it exists. So it's an infinite expansion. So I wrote no thickness here, so it doesn't have a depth to it. So it's just like the surface of a rectangle that's infinitely big. And so we have that as a plane. And then I'm going to talk about a defined term. So one of the next things definitely has a definition, and that's going to be space. All right, space is boundless. So there's no border to it. So it is a boundless collection of all points. So this is going to collect all of the points that make up your lines, your planes, or any individual points. All the points that are a collection of your geometry are found in space here. And so the next thing that I want to do is I want to talk about collinear. that's an important term that we should know the definition of. So collinear means that it exists on the same line. So if 2 points are collinear, they both live on the same line. The next word we want to talk about defining is coplanar. So if collinear are things that exist on the same line, coplanar is going to be things that exist on the same plane. All right, so we have 3 definitions here for words, and we have 3 undefined terms here. So these are things that are kind of foundational for when we're talking about geometry, and we need to make sure that we know these. The next thing I want to talk about is intersection. If you think about intersection, what do you think of? Do you think of driving up to an intersection in the road, and so you have another road that passes in front of you, and so you sometimes have stop signs or traffic lights there to help direct the traffic at these intersections. So we want to think about that. In geometry, there are intersections that we want to talk about too. And one of them is going to be the intersection of 2 lines. So if I have these 2 lines, what is this intersection in the middle? Well, it's just the single point. They cross at one point. And so if we look at lines intersecting, we get a point. Now the next thing to think about is planes. If we intersect 2 planes, what does the intersection of 2 planes look like? It is a little difficult to represent planes intersecting on this 2-dimensional surface of the whiteboard because this is something that really happens in more than 2 dimensions, but I've made an attempt to draw 2 planes intersecting, and so you see that as 2 planes are coming together, they're going to intersect at a line. And so when we intersect lines, we drop back to the next undefined term of points, and when we intersect planes, the same thing happens. We drop back 1 place to the line. All right, we've talked about a line, and now we're going to talk about what happens when we take a piece of that line out. So this is going to be a line segment. So we know that a line is an infinite string of points that are pulled together tautly so that it is a straight line. And we can take the line and cut it at any point and create a break in that, and we get a few different things from that. If we simply cut it at, say, D here, the right-hand part of this, from D on, this is going to be a ray. It has a initial point, and it goes on infinitely in the opposite direction. So we can create a ray here. And then, of course, we could do that on the other side as well. You see from here on, where we cut it, it goes infinitely the other direction from the point D. So where we cut it at D, it goes on infinitely this direction. So we get 2 rays out of this. The other thing that we could do is we could take this segment out. We could cut it in 2 places. Say, cut it at A and C. And so we have a line segment here. And since this is a finite piece as opposed to this infinite piece, this really helps us with the idea of measurement. We can measure this length fairly well. It doesn't really do us any good to try to measure something that's infinitely long because it's always going to be an infinite measure, but something that is finite like this, we can measure. And so we can figure out how long this is, or in the same line of thinking, we can find out the distance between A and C. So this is a line segment. The other concept that we want to talk about is the betweenness of points. So given any line being a sequence of points, if you choose any 2 points, there is a point between it. So if you say choose B and D, point C is between it. Now I don't have an infinite number of points marked on here, but if you needed to know what D was between, choose the next point further on, and you can designate a label for it, maybe I. And so between C and D, or between C and I, is the point D. So this happens anywhere. Even if you don't see the labels on there, there is some point that exists on there, which the point that you're looking at exists between. That is the betweenness of points. And that's an important term. A very similar idea to this that you've probably already seen is when you create a number line in, say, middle school, you list all the numbers on there. And if you're on the real number line, between any 2 numbers is another number. So we already understand this concept of the betweenness of points because we understand that between any number on the real number line, there's another number in between there. It doesn't matter which numbers that you choose. So this geometric concept is already kind of in the back of our mind when we think of the real numbers. I want to start to show the notation that you would use so that you can manipulate these geometric concepts kind of like you would manipulate something algebraically. You assign variables to things in algebra. We use the labeling of what we have geometrically to manipulate it. So if we look at our array D, there is D on, and we've already said that on the parent line there was this other point I, so I'm going to go ahead and put I on my ray diagram. And so if we want to talk about ray, this ray here that we've created in maybe a more abstract or algebraic sense, we could label it D I and then put this little arrow here, and the arrow should go in the direction that it's moving from the initial point towards the infinite side. So since the initial point was D, we put the arrow moving that way. For the line segment that we have here, we have A and C are the endpoints for our segment, so we would write AC and put a bar over top of it, and that would designate the line segment. For the entire line here, I had A and I here as my extreme labeled points, so we could do something like AI and put a double-ended arrow on top of it, and that would be the designation that we use symbolically to represent this line. So those are a few labeling techniques that we use as we discuss and manipulate things algebraically. With these things in mind, we could go back and look at maybe some addition with these terms. So we had broken our original line segment at D. So we had segment DI up here. The other half of that is D going through A the other way. So what we really want to say is that this ray plus this ray is equal to this line, AI. We can have this arithmetic of geometric objects that we can write this abstractly and manipulate. So that is why some of these labeling techniques are important, and we want to understand the symbol so we know what we're talking about. So 2 rays can be added together to create a line. Cheerful calculations.